All right, so this is lesson 5, special triangles, exact values, and the unit circle. And this is actually a lot of the same stuff that you already did back in Math 20-1. So if we imagine you have a triangle, it's got a radius of 1 or a hypotenuse of 1 and 45. If this is 45 and this is 90, this must also be 45. And that means these two things must be the same. So it has to be isosceles. So now by Pythagoras' theorem, we can go x squared plus x squared, a squared plus b squared equals c squared, which is my 1 squared or just 1. I can change this to 2x squared equals 1. Dividing both sides by 2, I now get x squared equals 1/2. Now what I do is take the square root of both of those. So x equals root 1 over root 2, or 1 over root 2. And I'm just going to multiply top and bottom by root 2 to rationalize. So I get x equals root 2 over 2. So both of my sides now have a value of root 2 over 2. That's the thing there. So now with my 45s, I can go sine of 45 would be my opposite, which is root 2 over 2, over my hypotenuse, which is 1. So that's just root 2 over 2. Same thing here. Cos is going to be the adjacent side. Hey, that's the same value. Still root 2 over 2 and root 2 over 2. Tan is going to be this thing divided by this thing. Since we already decided they were actually the same value, that's 1 and 1. Okay, here's our 60. In 60, this would also be 60, and this would also be 60, and then halfway across would be the 30. So it turns out that if this whole thing here is 1, this is 1/2, right? Now, if we have that, this piece here is, again, a squared, b squared, c squared. C squared equals, try that again with an actual equal sign, equals 1/2 squared plus y squared. Okay, so we'll call this y right here. Then I get 1 equals 1/4 plus y squared. Y squared equals 3/4. Y then equals root 3 divided by root 4, which is just 2. So that's root 3 over 2. So my sine 60 is going to be the root 3 over 2 divided by 1, or just root 3 over 2. Same again for pi thirds, same value. 1/2, 1/2. This is going to be the opposite divided by the adjacent. So root 3 over 2 divided by 1/2, which is the same as root 3 over 2 times 2 over 1. So just root 3. Yeah, not bad there. And that's the same again for pi thirds. This is basically the same thing, except sideways. So that's 1/2. This is also going to be root 3 over 2. So my values here are 1/2. Both those values together. Here, root 3 over 2. And here, 1/2 over root 3 over 2 is the same as 1/2 times 2 over root 3 equals 1 over root 3. Or if you would rather have it rationalized, root 3 over 3. Personally, I prefer it like this, but a lot of your teachers may enforce you to do it like that. Okay, so those are our special triangles. Here they go. This is 1/2 root 3 over 2, 1 over root 3, root 2 over 2, root 2 over 2, 1. What is this one? Oh, pi thirds. Okay, never mind. Root 3 over 2, 1 over 2, root 3. So those are all the values that we just got in our investigation. I'm not just pulling those out of my head. In my hypotenuse, with my hypotenuse 1, the sine is my opposite divided by hypotenuse, so that's just y. My cosine is just x, and my tangent would be y over x. So y over x is the same as the slope. Here comes the gibberish for the year. Sine cosec's tan. Too much there. There we go. So sine is the y, the cos is the x, and the tan is the or the y over x, the slope. Lovely. Now the book talks about having some way of remembering these things like 7 yellow rabbits or whatever. I prefer sine cosec's tan. So y values, this is a half, this is then root 2 over 2, and this is root 3 over 2. And then you can see that that corresponds to the height at that place. So if that's 1/2, this is root 3 over 2, root 2 over 2, root 2 over 2, root 3 over 2, 1/2. And this would be 0, 1, and this is 1, 0. Now, those are the same things we just saw. We've just taken the values we just found out of our triangle and plugged them into this thing. Now, personally, I really prefer just having these things nicely memorized, and they are stupidly easy to memorize. If you start with this, this is the point 1, 0. This is the point 0, 1. Back to my super fast lesson. So I've got my coordinate grid with my 1, 0, and my 0, 1. I'm going to have my 4 other lines in here, 3 other lines. So here's my 30, 45, and 60. And then I just write the coordinate places for all 3 of them. Now, we just have to be able to count to 4. You might not notice it, but that 1 is the same as root 4 over 2. In fact, all of these values are root something over 2. And the values of that something are everything from 0 to 4 as whole numbers. So this one's 0, so it's going to then count up. So this is going to be 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2. This is already root 4 over 2, so it's going to count down. Root 3 over 2, root 2 over 2, 1 over 2, and 0. So that's the way you create these. Just count to 4. 0, 1, 2, 3, 4, 4, 3, 2, 1, 0. So those first 4 points just really get the whole thing going. Now, if we include all of this value, I'm just going to go through. My sine is the y value, so it's 0 here. 1 over 2, root 2 over 2, root 3 over 2, and root 4 over 2, which is just 1. This starts at 1. Root 3, oh, here we go, I put in a 4. My brain's going faster than my hand is, evidently. So 4, 3, 2, 1, 0. My tangent is 0 here. Here it's 1 over root 3. Here it's 1. Here it's root 3. And then here it's undefined. Or if you prefer, you can even write the little infinity symbol. Because it's a vertical tangent line. The tan is the slope. So my rise is 1, but my run is 0. So that's where all those values came from. Sine ratio increases from 0 to 1. Cosine goes from 1 to 0. Tangent ratios are equal to the sine over cos. Again, sine is y, cos is x, tan is y over x. There. Now, this is our whole unit circle. Again, the way we build this is just counting up, counting down. So I've got 2 really nice patterns that I'm going to demonstrate here. The first pattern is your coordinates. Your coordinates are always root n over 2, and then you always just start with your 4 axes. So 1, 0, 1 is 4, so 3, 2, 1, 0. Then -1, -2, -3, -4. -3, -2, -1, 0, 1, 2, 3, 4. There's all your x coordinates. Just count up and down twice. Now onto the y coordinates. 0 starting, so 1, 2, 3, 4, 4, 3, 2, 1, 0. -1, -2, -3, -4, -3, -2, -1, 0. So they just keep counting up and down and all around. All right, so that's how those all work. My other pattern that I really like is for my radian values, and that pattern for the exact values is this. In your first quadrant, you just have pi over m. The m stands for my denominator. Why m? I don't know. Maybe I should use d. In fact, let's do that. I'll teach it a little bit differently. We're going to go for d, pi over d, where d is your denominator. Huh? That makes sense. Now, what we have here is in this quadrant, it's always my denominator -1. See how this is 6, there's 5, 4, 3, 3, and 2. So it's denominator -1. So d minus 1 pi over d. In this case, it's always denominator +1. And in this case, it's always twice your denominator -1 over d. And that's always with pi in the numerator. So those two patterns and all of your 40/80 values are all figured out. The other thing that I like to add into my own unit circle is my slopes, 0, 0. This is the 1 over √3 because it's my shallow line. And if I look, this is actually the exact same line. So this is always 1, or also 1 over √3. This is the slope of 1, 1, √3, and √3. These are the same three slopes. I'm going to put infinity because I'm too lazy to write undefined. These three here are the same three slopes. They're just negative. Negative √3. It's √3 because it's the steep one, right? The same family of graphs. Negative √3. -1, -1, -1 over √3, -1 over √3. And now your unit circle is everything. We've got our slopes on there. So sine, cosec, tan. So my sine is my y, my cos is my x, my tan is my slope. So that's how I like to go through it. Sine is y, cos is x, and this is my slope. So now we just use our unit circle. It's really easy. We play Where's Waldo? Sine of 300. So the first thing I do is I look at 300. Oh, there it is. My sine is the y value. Oh, there it is. Negative √3 over 2. My cos of 300, if I look back to the same thing, is 1/2. My tan of 300, so we can back to 300. My tan is right here. It's my slope. Now, all of these are just then flipped. So this would be -2 over √3. Rationalizing my denominator gives -2 √3 over 3. Secant is going to be 2 over 1. Cotan is going to be -1 over √3. Or rationalizing. There we go. Unit circle, exact value of cos, 3 pi quarters. 3 pi quarters is right here. Cosine is the x coordinate, so -√2 over 2. Cotan of 5 pi thirds, that's silly. What I actually want to do is find tan of 5 pi thirds, and then I'll flip it. So tan of 5 pi thirds, tan of 5 pi thirds is going to be down here somewhere. My tangent is -√3. So flipping it is going to be -1 over √3. Or if I really wanted, -√3 over 3. Tan of 600. Now this is a little bit tricky, because this is a rotation angle, and I need principal angles for my unit circle. So 600 minus 360 is going to be tan 240. So I go back over here, tan of 240 degrees. There's my 240. Tan is √3. So √3. Cosecant of 3 pi. Again, I go, that's really silly. What I actually want to know is sine of 3 pi, and then I will flip it. Always flip the output, not your input. So going around, 1 pi, 2 pi, 3 pi, and so the sign is the y value, so that's 0. So 1 over 0, but that's undefined. So cosecant of 3 pi, undefined. Use your calculator to find the stuff that corresponds to 2 pi fifths. So if I go sine of 2 pi fifths, making sure that I'm in radian mode, radian sine of 2 pi fifths. That's my y coordinate. Gotta give myself some more space here. 9511, and then my x coordinate is going to be the cosine of that. Actually, let's do this. Watch this trick. Second enter to get me back the same thing, and now I just push cosine. 0.3090. So 0.3090. And then those are my coordinates. All right, so this one here, class example 4, is like my favorite question ever. Brilliant. So what they've got is they've got 2 points on the unit circle. So the first thing I do is find those 2 points. Positive root 2 and negative root 2, that's going to be here, and it's my 45 family. So do they want it in radians and degrees, apparently. So this is going to be 315, or 2 twice my denominator minus 1, my denominator is 4, so 7 pi quarters. Now my other point, Q, is negative 1/2 root 3 over 2. So that's going to be here. And that's in my 60-degree reference angle. So that's going to be 120 or 2 pi thirds. That's my denominator minus 1. So 3 minus 1 is 2, 2 pi thirds. So now what I need to do is go counterclockwise from P to Q. This is P, and counterclockwise, the clock runs that way, so counterclockwise is going to run that way. So it's going to go like this. Did I do that right? I'm about 40% sure that I did. Clock. Where's the clock? No, I did my counterclockwise wrong. Ha! The clock runs that way, so counterclockwise is going to run that way. Don't judge me because I don't know which way a clock runs. So P is this one, so that's the angle we want. That makes more sense. That's kind of what I thought I was supposed to be getting. Remembering other times. Simple things like which way does the clock go? Okay, so now my reference angle here is pi quarters. So this little piece here is pi quarters, and then the rest of this is 2 pi thirds. All of this bit is 2 pi thirds. So that total angle is pi quarters plus 2 pi thirds. So in radian mode, I'm going to take out the pi, and then I'm going to go 1/4 plus 2/3, and I'm just going to let my calculator do that for me. Why? Because I don't want to do it. 1/4 plus 2/3 should be 3/12, 4/12, 7/12, I think. Let's check. Math frac. 11/12. I was only off by like 4/12. Who's counting? Oh, that's because I did pi thirds, not 2 pi thirds. Smart. Anyway, so 11 pi twelfths is my answer in radians. That's my radian answer. In degrees, it's going to be 45 here and 120, so that's 165 degrees. Or I could just turn this into degrees. So I could go, am I already in radian? And go into degree mode, watch this trick here. And then second quit. So now I can go 11 pi twelfths. Close my bracket, so I need a starting bracket here. Insert me a starting bracket. And then I'm in degrees, so now I go second angle, tell it that it's radians. There's my 165 degrees. Okay. this one here without using a graphing calculator. See, if this was a test, I would ignore that instantly. But I need to do log base 2 of cos of 7 pi quarters. So the first thing I need to do is think about cos 7 pi quarters. Those of you who are in my AP program, don't worry, we'll do logs in a couple of months. But for my standard course, we've already done logs, so we should be able to work this through. So cos of 7 pi quarters is down here. My cos is negative root 2 over 2. Nope, positive root 2 over 2. Huh, look at me go. That's the sign would be negative, but the cos is definitely positive. So this is log base 2 of root 2 over 2. Use my laws of logs. Log base 2 root 2 minus log base 2 of 2. This is same as 2 to the 1/2, so that's just going to be 1/2 this thing. And this thing's minus 1. So 1/2 minus 1 is negative 1/2. Wunderbar. Unit circle. Find the thing. So if this is on the unit circle, I know this is my x. So cos of theta equals negative 0.6157. Now, I'm going to put that into my calculator. Again, I don't use the negative value, right? So if I'm looking for the angle, I still use my cos negative 1, 0.6157, close my bracket, ba-bam, so my reference angle is 51, but because both of these are negative, I've got to be down here in quadrant 4. So, oh shoot, I'm in degrees. Well, I'll keep going with this. So 180 plus that reference angle is going to be that measure in degrees. And determine the value of theta, where theta is the angle made by the positive x-axis in the line passing through A. They never said whether they wanted degrees or radians. So you know what? We're good. 231.9 degrees. Okay. Onwards. Yeah, don't even worry about this. Don't even show it. Not really. Just use your unit circle. This is not entirely in the course, or not specifically in the course, but it kind of comes out of stuff, and it comes up on the diploma every now and again. So the Pythagoras theorem, if this is the point x comma y, it gives me these coordinates as x and y, and then I have a right triangle, so Pythagoras theorem should work, and I get x squared plus y squared equals r squared, which is 1, if and only if it's the unit circle. If we're doing some other radius circle, where this is then x, y, and r, it would be x squared plus y squared equals r squared. Same idea. Which of these points is on the unit circle? Well, all I have to do is square them. 1/4 plus 1/4. That does not equal 1, so not on the unit circle. This one, 16. I don't want to do it in my head. I probably could do it in my head, but 65 squared, not so much, nor 63 squared for that matter. So 16 divided by 65 squared plus bracket negative 63 divided by 65 squared. Oh, look, that's 1. That one's on the unit circle. So says my calculator. And I am good with that. For this one, I can do these ones in my head. Negative 2/3 squared is 4/9. Root 5 squared is 5. 3 squared is 9. So 5/9. So 9/9 equals 1. Yes, that one is on the unit circle. This one is just basically the same idea. So negative 1/5 squared plus y squared equals 1. Why 1? Because unit circle. And now I just need to go y squared equals 1 minus, again, when I square this, it'll be positive 1/25. So minus 1/25, 24. 25ths, determine the exact values of y. Okay, so my exact values are going to be root 24 over 5, root 24 by jailbreaking it out to 12, to 6, to 3. So it's going to be 2 root 6. And then in quadrant 3, it has to be negative. So in quadrant 3, x and y are negative. So negative 2 root 6 over 5. So if I were to draw this, it's going to look like that. Negative 1/5 and negative 2 root 6 over 5. So secant, and 1 for me to circle, secant is inverse of cos. Cos is adjacent over hypotenuse. So cos theta equals negative 1/5 over 1, or negative 1/5. That means secant theta equals 5, negative 5 I should say, negative 5 over 1. Cotan is 1 over tan, so tan theta, and then I'm going to flip it. Tan theta is my y over my x, so negative 2 root 6 over 5 divided by 1/5, but that's the same as times 5 over 1. It's going to be positive value, 5's cancel, so just 2 root 6. And then the cotan is then 1 over 2 root 6. Rationalized is then, goodness gracious. Okay, I've got lots of stuff going on here. Let's move this over. That little shaky thing worked. Okay, so 6 over 2 times 6. So root 6 over 12. Whew, that was ugly. Could be done though. And then last one, equation of a circle with center at the origin, radius 8. It's just going to be x squared plus y squared equals r squared, which is 64. The point is on the circle, then this is just going to be negative 4 squared plus b root 3 squared equals 64. 16 plus 3b equals 64. 3b equals 64 minus 16. 48, I think? That sounds moderately right. Divide both sides by 3. 16 is my b. And I guess positive or negative b. Plus or minus 16. Because when we squared it. Oh, wait a sec. No, b squared. B squared. B squared. Plus minus. B equals plus minus 4. I forgot to square my b. How embarrassing. Okay, that's lesson 5. Enjoy. As always, if you have questions, bring them in.